Hello children, today we are going to discuss chapter carbon and its compounds. It is most important chapter from organic chemistry from class 10. This is fourth chapter of NCERT book. Carbon occurs in nature, in living organisms in the form of carbon dioxide, carbon monoxide around us. It is present in our fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas. It is present in the form of carbonates, hydrogen carbonates. Carbon can be found in diamond, graphite, fullerenes. Whatsoever we can see around us, most of the things are containing carbon in them. Carbon is most versatile element present around you. Without carbon, you can't imagine your life. Even your clothes, your food, medicines, pesticides, insecticides, whatsoever are the things around you. Most of them are made up of carbon in one or the another form. Either they are direct carbon compounds or they are derivatives of carbon. Carbon is having 6 electrons in it. It is having configuration 2,4. In first shell it is having 2 electrons. In second shell it is having 4 electrons. Carbon can either gain or lose 4 electrons to complete its octet. But generally it can't. Carbon if tries to lose 4 electrons. What would be the problem? See, carbon is having initially 6 protons and 6 electrons, right? Carbon is having protons 6 and electrons are also 6. But if carbon wants to gain 4 electrons, at that time, carbon will have 6 protons with 10 electrons. It is for C4 negative. If carbon wants to gain 4 electrons, what will happen? Second shell will have now 8 electrons. And nucleus with 6 protons has to hold 10 electrons. Then forces of attraction with the nucleus will be very less now. So when attraction is less, repulsion comes into play. There would be repulsion, and because of repulsion, it will become unstable. So nucleus with 4 protons can't hold 10 electrons. That means it will be unstable structure. So carbon will not gain 4 electrons. In another case, if carbon wants to lose 4 electrons, for losing 4 electrons, it needs large amount of energy which can't be made available. So carbon will not lose or gain 4 electrons. That means it will not make ionic bond. Rather, it will make covalent bond by sharing its 4 electrons with other atoms. Like you have seen this, carbon is having 4 electrons which it is sharing with hydrogen and completing its octet. It is structure of methane. In this structure, you can see carbon is having one bond. This bond, which is shown with solid wedge, it is bond towards the observer, and this is bond away from the observer. These two bonds are in one plane, right? So out of these four bonds, this is three-dimensional representation of carbon compounds. The solid wedge is showing bond towards the observer. This dashed line is showing bond away from the observer, and these two lines are showing bond in one plane, right? And bond angle between them is 109 degree 28 minutes. Carbon is sharing 4 electrons, completing its octet and attaining noble gas-like configuration. So it will become stable. Covalent bond is formed by sharing of electrons which are having almost similar values of electronegativity. If you are having one metal, another non-metal, one electropositive, another electronegative element, then of course they will get ionic bond formed. In that case, metal will donate electron and non-metal will gain electron. But if you are having similar kind of elements, you are having two hydrogen atoms, you are having two nitrogen atoms, two oxygen atoms, then what will they do? They will share electrons. By sharing electrons, they are making covalent bonds between themselves. Here you are having hydrogen. Hydrogen is having one electron in outermost shell, another hydrogen atom with one electron in outermost shell. So they both are sharing one electron. This shared pair of electron remains in between the two, and both are getting that feeling that they are having their complete octet. But this shared pair of electrons stays between them. It is like we can give here one example. There is one chapati and there are two dogs, right? These two dogs are attacking on the same chapati. By the time that chapati is in between them, at that time they are bonding to each other by this shared pair, by that chapati, right? See this oxygen atom. Oxygen is having 6 electrons in outermost shell. So it is deficient by 2 electrons. It wants to gain 2 electrons to complete its octet. So oxygen will share 2 electrons between themselves and completing their octet. See, this is structure of oxygen atom. Oxygen is sharing 2 pairs of electrons and it is completing its octet. In case of nitrogen, nitrogen is having atomic number 7, so its configuration is 2,5. It wants to gain 3 electrons to complete its octet. So they will share 3 pairs of electrons between themselves and they will complete their octet by sharing 3 pairs of electrons. A number of pairs, how many they are sharing, will decide their bond order. Like in case of nitrogen, we are sharing 3 pairs of electrons. So there would be nitrogen, nitrogen, triple bond as they are sharing 3 pairs of electrons. They are having 5 electrons in outermost shell. They are sharing 3 pairs of electrons. Like this. They are making nitrogen, nitrogen, triple bond. This is structure of N2. Bond order here is 3. In case of oxygen, oxygen was sharing 2 pairs of electrons. Oxygen is having 6 electrons in outermost shell. So it is sharing 2 pairs of electrons and they are making O2. This is structure of O2. Bond order in oxygen is 2. This is structure of H2. This is structure of fluorine molecule. Fluorine is having 7 electrons in outermost shell as it is having atomic number 9. So configuration will be 2, 7. So fluorine is sharing 1 electron with another fluorine atom to make structure of F2. Then you have structure of CO2. Carbon is having 4 electrons in outermost shell and oxygen is having 6 electrons in outermost shell. So oxygen will share 2 electrons with carbon and this another oxygen atom is sharing 2 pairs of electrons. They are sharing 2 pairs of electrons between them. This is structure of CO2. CO2, we are having 2 double bonds on both sides of carbon. It is a non-polar covalent compound. On both sides, same type of oxygen atoms are there. So it is structure of CO2. This is CF4. Fluorine is sharing 4 electrons with carbon. In place of this, rather we can make CCl4. That would be the structure CCl4. Fluorine being more we can say explosive types of reactions fluorine is showing. So rather we will make CCl4. It would be the structure. CCl4. Chlorine is sharing 1 electron with carbon. All the chlorine atoms are sharing 1 electron. This is CCl4. This is formation of methane. Carbon is having 4 electrons in outermost shell. Hydrogen is having 1 electron in outermost shell. So it is sharing 1 electron with carbon. Hydrogen in this case is completing its duplet and carbon is completing its octet. So this would be CH4, methane. In another case, we are having two carbon atoms. They are sharing 1 electron pair between them and they are sharing 1 electron with 3 hydrogen atoms. That would be the structure of C2H6. What we have to do to initiate this structure, firstly we will take carbon atoms. Like you are having two carbon atoms. Carbon is having 4 electrons in outermost shell, right? Draw both the carbon atoms with 4 electrons. Now it is sharing 1 electron with hydrogen. Hydrogen is completing its duplet. This is hydrogen atom completing its duplet. And carbon atom is completing its octet. This is structure of C2H6. We are having three major allotropic forms of carbon in which carbon is in free state. Diamond, graphite and Buckminster fullerenes. We will discuss them one by one. Diamond is hardest non-substance. It is used to cut glass. We know it. It is a colorless, transparent solid having extraordinary shine. When light falls on it, it reflects that light into different angles. Because of that, it gives shiny look. It is hardest non-substance. It is used for glass cutting. In diamond, every carbon is binding with 4 other carbon atoms by making strong covalent bond between them. Hence, it is having high melting point. This is carbon atom. It is sharing 4 electrons with other carbon atoms. In this way, it is tetrahedrally joined with other carbon atoms and it is gaining this type of structure in which bonds are very strong. Every carbon is binding with other carbon, 4 carbon atoms, leaving no electron free. So diamond is bad conductor of electricity. It is not having any free electron. Diamond as tools are used to operate cataract. Cataract, if somebody is having motiabin, so in doing that surgery, in operation, doctors, surgeons, they are using diamond as tools to pick up that layer of cataract. Second is graphite. Graphite is grayish black opaque substance which is present as pencil lead, right? It is soft and slippery in touch. In graphite, there are three layers, three carbon atoms which are joined. See, one carbon atom is having bonding with 3 other carbon atoms and fourth electron is free. Because of that free electron, it can conduct electricity. As it can conduct electricity, so it is used to make electrodes in cells. Graphite rods are used as electrodes in making cells. Graphite is used for writing. When you are writing with pencil, what you are doing, you are removing one layer of carbon. This is a layered structure which is present in graphite. So when you are writing with pencil, you are writing with one layer. This is a layered structure which is present in graphite. It is also used as lubricant, as greasing agent. Graphite is having high melting point, so it is used to melt metals. The crucibles will be made up of metals. The crucibles will be made up of graphite. Suppose you want to melt any metal. So the container, the vessel in which you will melt that metal will be made up of graphite. Then you have Buckminster fullerene. Fullerenes are dark solid substances. They are present in the form of 60 carbon atoms. Initially, it was first was made up of 60 carbon atoms, then C70 to 250 तक बने हैं ये, ठीक है? In carbon atoms, they are arranged in the form of football. It is like a geodesic dome present as a structure in US. It is similar to that structure, that wise it is called Buckminster fullerene. Buckminster fullerene is a architectural structure which is present in US. Then formation of very large number of compounds. This is also called versatile nature of carbon. Carbon is a very friendly element. It makes large variety of compounds. And what are the major causes why carbon is making large variety of compounds? First is carbon is having tetrahedral structure. Carbon is having valency of 4. It can combine with 4 other atoms at a time. These 4 atoms can be same or different. So depending upon that, it would have large number of compounds. Carbon is showing catenation to maximum extent. Catenation means self-linking property. Carbon can combine with other carbon atoms to form straight chains, to branched chains, to close ring structures. That's why it can make large variety of compounds. Carbon can bind with hydrogen, oxygen, nitrogen, halogens to larger extent. And if we want to have some more subtopics in it, then we can write multiple bonds, like carbon can make single, double, triple, all types of bonds. And along with that, it is showing isomerism. Isomers are the compounds which are having same molecular formula but different structural pattern. Because of that only, we are getting more maximum number of compounds. Hydrocarbons can be further classified as saturated and unsaturated hydrocarbons. Saturated means those which are having carbon-carbon single bond. Unsaturated are those which are having carbon-carbon double or triple bond. Like you are having alkanes. Alkanes are those which are having carbon-carbon single bond. Like we are having here methane, ethane. These are the structures. How we have to draw? Carbon is having 4 electrons in outermost shell. It is sharing 4 electrons with hydrogen and is completing its octet. Hydrogen is completing its duplet. This is first structure. Then in second structure, you are having 2 carbon atoms joined together and they are completing its octet by sharing electrons with hydrogen. 1 electron is shared with carbon and 3 electrons are shared with hydrogen. For writing the names, for carbon 1, we are having word root myth. For carbon 1, we are having word root myth. For 2, eth. For 3, prop. For 4 carbon atoms, it's but. For 5 carbon atoms, it's pent. For 6 carbon atoms, X. These are word roots. Then we have primary suffix. For carbon-carbon single bond, we will write ane. For carbon-carbon double bond, it is ene. For carbon-carbon triple bond, it's ine. Now see, you are having carbon-carbon single bond, right? For one carbon, we will write meth, and for single bond, we will write ane. So its name is meth plus ane. It's methane. For two carbon atoms, we write word root as eth, and primary suffix is ane. It's eth plus ane, ethane, like that. Then you have unsaturated hydrocarbons. Unsaturated are those which are having double or triple bond between carbon atoms, like we are having alkenes or alkynes. Alkenes are those which are having carbon-carbon double bond. For them, primary suffix will be "ene," and those which are having carbon-carbon triple bond, they are called alkynes. Alkynes are having suffix "yne," "yne." Right? Now, why carbon is making double bond? This is a question. Suppose you are not having that much hydrogen available as is required. So what carbon will do? See, carbon is having two carbon atoms and with four hydrogen atoms. Then how to make its structure? Carbon is having four electrons. Another carbon atom is having four electrons. So it is sharing one electron with hydrogen. It is sharing another electron with hydrogen. It is also sharing two electrons with hydrogen in same way. Carbon is completing its octet by sharing two pairs of electrons with another carbon atoms and two bonds with hydrogen atoms in this way. And this is another carbon atom completing its octet. Hydrogen is completing its duplet. In this way, it will make carbon-carbon double bond. This would be the structure. Now see, in this case, you are having C2H2. What carbon will do? Carbon will share three pairs of electrons with another carbon atom, and one bond will be made with hydrogen atom. In this way, hydrogen is completing its duplet and carbon is making its octet. This would be the structure. Then we have isomers. Isomers are the compounds with same molecular formula but different structural pattern. They are showing different structures, like you are having here butane. You are having normal butane, C4H10. With this structure, it is normal butane. If you are making branched structure, then it is isobutane. More isomers can be made for pentane, like you are having 5 carbon atom chain. This is normal pentane. Then one side branching, it is isopentane. Both side branching, it is neopentane. These are different structures with same molecular formula. They are called isomers. Next, we are having functional groups. Functional groups are group of atoms that decides properties of carbon compounds. We are having different functional groups. First group is halide. In halide, we can have chlorine, fluorine, bromine, iodine in place of one hydrogen atom. Here you are having series of alkanes, methane, ethane, propane, butane, pentane, hexane, and we are replacing one of the hydrogen by chlorine. So you will get CH3Cl. And for writing the name, what we have to do, we have to write prefix for that halide. Prefix is added before the name, so its name will be chloromethane. Its name will be chloroethane. Its name will be chloropropane. In this manner, you can write full homologous series. Homologous series is that in which difference between adjacent compounds is 1 CH2 unit, that is 14 unit mass, and with that is same functional group. So it is a homologous series of halides. Second functional group is alcohol. In alcohol, you have to replace one of the hydrogen by OH group. So you will write here CH3OH, C2H5OH, C3H7OH. From the compound from which it is derived, you can write the name. It was derived from methane, so its name will be methane plus ol. You have to write suffix as ol, OL. So its name will be meth plus ane plus ol. You have to omit this E before writing ol. So omit this E, its name will be methanol. Its common name is methyl alcohol. Similarly, you have eth plus ane plus ol, prop plus ane plus ol, but plus ane plus ol, pent plus ane plus ol, hex plus ane plus ol. These will be the compounds: methanol, ethanol, propanol, butanol, pentanol, hexanol. Again, they are making homologous series of alcohol group. Then you have aldehydes. In aldehydes, we are replacing one of the hydrogen atom by CHO group. Actually, what we have to do to make the structure, see if you are having methane. This was methane. What you have to do, you have to remove two hydrogen atoms. Remove these two hydrogen atoms. In place of two hydrogen atoms, add one oxygen atom. We are replacing two hydrogen atoms by one oxygen atom. So it would be HCHO, HC double bond OH. This is methanol. Similarly, when you are having ethane, you are getting ethanol. Then from prop it is propanol, from but it is butanol, from pentane it is pentanol. These would be the structures. One common mistake what children does, they see this one carbon. They don't count this carbon with them. So both carbon atoms you have to keep in mind. Then only it would be ethanol. This is C2 and this one C. These are three carbon atoms you have to consider. So it will give you another structure C2 plus 1. 3 carbon atom, it is prop plus ane plus ul. Propanol, Al will be suffix for aldehyde group. Then for writing carboxylic acid, in carboxylic acid, what you have to do, write it in this way. This was methane. So what you have to do, you have to omit two hydrogen atoms. Omit two hydrogen atoms. In place of that, add one oxygen. And one oxygen is added with this H. So it would be HC double bond OH. It is HCOOH. Its name is ending with oic acid. It is meth plus ane plus oic acid, methanoic acid. Methanoic acid is having common name formic acid. Then you have eth plus ane plus oic acid. Ethanoic acid is having common name for acetic acid. Methanoic acid you can find in the ant sting. Ethanoic acid you can find in vinegar. Then you have ketone. In ketone group, like in aldehyde group, you have to add one oxygen in place of two carbon atoms. Like you are having suppose 3 carbon atom structure. Right? These are 3 carbon atom structure. What should be there? This was structure of say propane. So what you have done, you have removed 2 hydrogen atoms. It was CH3, CH2, CH3. So you have replaced 1 oxygen by 2 hydrogen atoms. In this structure, you have to keep in mind, carbonyl group के दोनों साइड पे मिनिमम एक कार्बन होना चाहिए, right? If there would be another hydrogen atom, तो ये बन जाएगा aldehyde. So it is different from aldehyde because in this minimum one carbon atom should be there. Ketone group will come in between the chain. Aldehyde group was terminal group. It was coming on the one side of chain only, right? It was terminal functional group and it is coming in between the chain. It is not like that terminal, it is bridged type, right? So minimum one carbon should be there. So it will start from 3 carbon atoms. For 1 and 2 carbon atom, there would be no ketone. Its name will end with one, O-N-E, one. So prop plus ane plus one will be propanone. But plus ane plus one, butanone. Pent plus ane plus one, pentanone. Hex plus ane plus one, hexanone. Like that. Homologous series. Homologous series is group of carbon compounds having similar structure, similar kind of functional group, and every conjunctive member is having difference of CH2, that is 14 unit mass. We are having alkanes, alkenes, alkynes, and all the functional groups. They are making homologous series. First is alkanes. Alkanes are having general formula CnH2n plus 2. Means number of hydrogen atoms are 2 more than double of carbon. You can write by filling the values here. We will fill value 1. Then H will be 4. So it will be CH4. Then you will put value of N as 2. Its value will be C2H6. Then C3H 3 2s are 6 plus 2, 8. In this way, you will fill all the values. For writing the names, as we have already discussed, for 1 carbon, we are writing word root meth. For single bond, it is ane. So meth plus ane will be methane. Similarly, for 2 carbon atoms, eth plus ane, prop plus ane, but plus ane, pent plus ane, hex plus ane, hept plus ane, oct plus ane, non plus ane, dec plus ane. In this way, you will be able to write names of alkane series. Then we have alkenes. Alkenes are those hydrocarbons which are having carbon-carbon double bond. They are unsaturated hydrocarbons. Their name will end with "ene." The suffix used for them will be "ene." So for writing the names, you will write eth plus ene. We will start with 2 carbon atoms because minimum 2 carbon atoms are required to make double bond. So we will fill values in general formula CnH2n, means number of hydrogen atoms are double than carbon. So it will be C2H4, C3H6, C4H8, C5H10. Similarly, their names are eth plus ene, ethene, prop plus ene, propene, but plus ene, butene, pent plus ene, pentene, and so on. Then alkynes. Alkynes are having general formula CnH2n minus 2, means number of hydrogen atoms are 2 less than double of carbon. They are having triple bond, carbon-carbon triple bond, and they are having suffix "-ine", Y-N-E, "-ine". So for two carbon atoms, you will write eth plus ine, ethyne, prop plus ine, propyne, but plus ine, butyne, pent plus ine, pentyne, hex plus ine, hexyne. And we are filling here values C2H2, C3H4, C4H6 in this way. Then if you are not having enough number of carbon atoms and you want to make only saturated hydrocarbons, then what is choice? Means I'm giving you a situation, you are having formula C3H6 and you have to make saturated hydrocarbons by using these number of carbon and hydrogen. Then what you will do? What is your choice? You will write first carbon series, right? They are having 4 electrons. Now see, they are having 6 hydrogen atoms. Fill these 6 hydrogen atoms. Right? We have written 6 hydrogen atoms. Now they are not have completed their octet. So what they can do? See, this carbon is having 1 electron, this carbon is having 1 electron. If they both will bend in this way and they will share this pair of electron with each other, then it will lead to a cyclic structure. It would be like this. This is cyclopropane. Cyclopropane is having formula C3H6. Similarly, if you want to draw for C4H8, its structure will be like this. They will join together and again they are having two hydrogens attached with them. That would be the structure. For 5 carbon atoms, they'll make a pentane type structure. In this way. So they will complete their valencies with hydrogen. Right? This is structure for 6 carbon atoms. You are having 6 carbon atoms and they are completing their valencies by sharing 1 electron with other end of carbon chain and completing their octets in this way. This is cyclohexane. We can generalize formula of cycloalkanes is CnH2n. It is similar to alkene, but they are saturated hydrocarbon. They are having all the carbon-carbon single bonds. Then comes a very special element. It is aromatic hydrocarbon. It is benzene. How we will reach to the structure of benzene? See, we were having structure of cyclohexane. If you will remove hydrogen atoms one by one, you are removing, say, this hydrogen atom and this hydrogen atom. Both hydrogen atoms, if you will remove, then they will get one double bond here. Similarly, if 2 more hydrogen atoms are removed, then one double bond will be generated here. If you will remove again 2 hydrogen atoms, then one double bond will be generated here. It will lead to structure of benzene, means cyclohexane minus 3H2 will give you structure of benzene. Let's understand how. This is structure of benzene. You can draw double bond to this side or to this side. Both ways it is correct, as it can share pair of electron to these carbon atoms or these carbon atoms. It would be fine. Then we are having chemical properties of carbon compounds. We are having types of chemical reactions which we will discuss one by one. We are doing combustion reaction, then substitution, addition and oxidation. All the four types we will discuss one by one. First is combustion. Combustion means when you are burning something in presence of air. Like you are having coal, you are burning it in presence of oxygen. It will give you carbon dioxide plus heat plus light. Means if coal is burnt in presence of oxygen, it acts as fuel. Hydrocarbons, when burnt in presence of oxygen, it will lead to carbon dioxide, water along with heat and light. So they are used as fuel. Similarly, you can take ethanol. Ethanol is burnt in presence of oxygen. It will give you water plus carbon dioxide plus heat and light. Ethanol can also be used as fuel. Sprit lamps we are using ethanol as fuel in them, right? So one thing we need to understand in combustion reaction is saturated hydrocarbons burns with blue flame while unsaturated hydrocarbons burns with sooty flame. If you are going to take hydrocarbons as fuel, then saturated hydrocarbons should be your choice. Your bottom of vessels will not get blackened with the help of saturated hydrocarbons, but with unsaturated hydrocarbons, soot will be collected at the bottom of the vessel. So your bottom will collect that unburnt carbon, which it will leave. What is reason? If you are taking, say, you are having three types of hydrocarbons. You are getting in question, suppose you are having C4H10, then C4H8, C4H6. Out of these three hydrocarbons, see, this butane is having more number of hydrogens than butene than butane, right? So more is amount of hydrogen, more is efficiency of fuel. We know calorific value is of hydrogen is much more than the carbon. It's 150 kilojoule per kg. So hydrogen will be a better fuel. That's why this butane, which is having more quantity, more ratio of hydrogen, will be a better fuel than butene, which is better fuel than butane. Then one more question is, some of the hydrocarbons burns with flame and some other burns without flame. Fuels which are not having volatile components will not burn with flame, and the fuels which are having volatile components in them which can vaporize will burn with flame. Like you are using candle wax. In candle wax we are having wick at the center. Wax vapors are rising up, they are burning. Wax vapors are rising up, they are burning. So they are leading to a flame. When coal is burned, it is not having anything volatile in it, so it will not burn with flame. Second type is oxidation reaction. Oxidation is addition of oxygen or removal of hydrogen. We will write this reaction. We are having C2H5OH. Write it in this way. What we have to do, we are removing hydrogen and we are removing hydrogen. In place of hydrogen, you are going to add oxygen. So remove this hydrogen molecule, H2 is removed. In place of it, we are adding one oxygen atom. As valency of oxygen is 2, of hydrogen it is 1. That's why it will be like this. Now it is structure of ethanoic acid. Ethanol on oxidation will give you ethanoic acid. Color of potassium permanganate or acidified potassium dichromate will start fading off as it will be consumed in the reaction. Next is addition reaction. Addition is a reaction which is used to convert unsaturated hydrocarbons to saturated hydrocarbons. How you will do this reaction? We will perform this reaction with the help of catalyst. Catalyst is a substance which is a surface provider. Catalyst provides a surface on which reaction takes place. Suppose you are having only gaseous reactants and you want to do this reaction, then rate of reaction will be very slow because most of the collisions will be elastic collision with no effective formation of product. That's why we need a surface on which these gases can stick and can form product. If I can give you example, like we are having two students, they are having balls in their hands and they want to collide the balls in air, then chances of collision will be very less. If you will give them a table, on that table they want to collide the balls, then rate of collision will increase. Similarly, this table is our catalyst. Say you are having surface of nickel, right? Nickel or platinum, these are used as catalyst. Catalysts are D block elements. They are having bigger surface, so they can provide surface on which reaction can take place. This is surface of nickel. First of all, hydrogen will come. Bond between hydrogen atoms will start breaking and bond with surface of nickel will start forming in this way, right? Then ethene comes. This is ethene. Bond between ethene molecules will start breaking. This bond will start breaking and bond with hydrogen will start making. This state where bonds are half formed and half broken is termed as transition state. After formation of transition state, these bonds will break, these bonds will form. So what you are going to do, you are having ethene, you are having hydrogen. We need to break this bond, we need to break this bond. In place of these two bonds, these two new bonds will be formed. So this is CH3, CH3. Your ethene is converted to ethene. Unsaturated hydrocarbons can form saturated hydrocarbons. You are having ethene, hydrogen is added in it. In presence of nickel or padmium as catalyst, it will lead to formation of ethane. This is reaction which is used to convert vegetable oil to vanaspati ghee. For the conversion of oil to ghee, we are converting unsaturated oils to saturated fatty acids. Next is substitution reaction. Substitution means a reaction in which more reactive element displaces another element. Like you are having here methane. In methane, when you are adding chlorine, one of the chlorine atom will replace hydrogen. You are having methane. Then we are having chlorine. HCl we need to remove and chlorine is added in its place. It will lead to CH3Cl. Similarly, then CH3Cl will react with chlorine. It will give you CH2Cl2 plus HCl. This is chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Trichloromethane is also called as chloroform, and CCl4 is known as carbon tetrachloride. Chloroform is used as anesthesia to make the people unconscious. And CCl4 is used as organic solvent to dissolve organic compounds which are not soluble in water. Then we have some important compounds. We are going to discuss ethanol and ethanoic acid one by one. First, we are having ethanol. Ethanol is C2H5OH. It is component of hard drinks. Ethanol is colorless liquid with unpleasant smell, and it is having burning taste. Some people may find it pleasant, but it's your own choice. It is soluble in water. Ethanol reacts with sodium to form C2H5ONA plus hydrogen gas. This is reaction where sodium, being more reactive, displaces hydrogen from this, and it is forming sodium ethoxide plus hydrogen gas. Ethanol, when reacts with concentrated sulfuric acid at 443 Kelvin temperature. Temperature is must thing you have to write here. 443 Kelvin temperature. It will give you ethene. How to do this reaction? You are having ethanol. This is ethanol. We are using concentrated sulfuric acid as dehydrating agent. Dehydration means removal of water. So water will be removed from this in presence of concentrated sulfuric acid in this manner, OH negative, H positive, and this bond will shift in between these two. So it will be CH2 double bond CH2. Ethanol will be converted to ethene. But if you are doing this reaction at 413 Kelvin temperature, suppose by mistake you have written temperature wrong, then you will not get any marks in this equation. The reason is if you are doing it at different temperature, then it will lead to another product. You are having two molecules of ethanol at 413 Kelvin temperature. You are performing reaction with sulfuric acid. Concentrated sulfuric acid will act as dehydrating agent. It will help to remove water, but one water molecule will be removed from 2 units of ethanol. So what would be the product? You will get ether. This is diethyl ether. CH3, CH2O, CH2, CH3. This is diethyl ether. This would be your product. So you need to mention here 443 Kelvin temperature. As at 413 Kelvin temperature, reaction product will be different. Ethanol is used for making alcoholic drinks. It is used as solvent for the substances which are not soluble in water. It is used to make tincture of iodine, cough syrups, and other tonics. Ethanoic acid. Ethanoic acid is colorless liquid with pungent smell and sour taste. It is soluble in water. 5 to 8% solution of ethanoic acid in water is vinegar. It is used to make pickles and other substances. It is used as taste enhancer in Chinese food. Then you are having a esterification reaction. In a esterification reaction, carboxylic acid reacts with alcoholic group and it leads to esters. In this reaction, this H and this OH, water is removed and you will get CH3COO C2H5. This is ethyl ethionate. Esters are sweet smelling substances which are used in perfumeries. Then we have saponification reaction. When you are taking that ethyl acetate and reacting it with NaOH, then what will happen? This is C2H5OH, ethanol plus CH3COO Na. This Na will come here. C2H5OH will removed out. It is formation of ethanol CH3COO Na. It is sodium acetate. This is sodium acetate. This reaction is saponification reaction. Then ethanoic acid reacts with NaOH. This is H from acid, OH from base. H and OH, water will be removed. CH3COO Na, sodium acetate is formed. It is neutralization reaction. Acid plus base gives you salt plus water. Ethanoic acid reacts with sodium carbonate. Ethanoic acid reacts with sodium carbonate. You have to take 2 molecules of ethanoic acid. React it with sodium carbonate, Na2CO3. Product will be CH3COO Na. This is CH3COO Na. Right? This is CH3COO Na. Plus this is H2O, right? Water and then carbon dioxide. Means metal carbonates reacts with acid to form salt plus water plus carbon dioxide. If you are taking sodium hydrogen carbonate, then CH3COOH plus NaHOCO2. It is CH3COO Na. It is water and it is carbon dioxide, right? So metal hydrogen carbonate reacts with acid to form again salt plus water plus carbon dioxide. So we can generalize metal carbonate or metal hydrogen carbonates. When reacts with acid, they gives you salt plus water plus carbon dioxide. Then last topic of the chapter is soaps and detergents. Soaps are long chain fatty acids of carboxylic acid. We are having here sodium stearate C17H35COO Na. This is structure. We are having this hydrocarbon chain. This is tail and this is polar head. This is hydrophobic in nature and this is hydrophilic in nature and this is hydrophobic in nature. Please correct it. It is hydrophilic. This is hydrophilic. Hydrophilic means water loving part and hydrophobic means water repelling part, right? This is soluble in oil. This is soluble in water. Why soluble in water? What is reason of being hydrophilic? As we know in chemistry, we are having a rule like dissolves like. So polar dissolves polar, non-polar dissolves non-polar. This is non-polar tail. This is soluble in oil and this is polar head. Water is also polar. It is having H positive O negative end. So because of that, this will be soluble in water. This is formation of missile. How it happens? See, you are having a cloth which is dirty. Dirt is because of anything oily or this is dirt. anything because of oil or grease, then mud sticks with it or dust sticks with it. Then it will turn to anything dirty. So you have to clean this dirt, right? You are having a stain, then you have to clean it. What you will do, you will take a container, you will take soap solution in it. Soap solution is taken in big container. What soap will do? Soap is having two types of ends. It is having this type of non-polar tail and it is having a polar head, right? Polar head means it is having positive negative part and this tail is not having any positive negative part. Now water is also polar. It is also having positive negative parts. So this head part will come towards water and this tail part will go towards oil. Oil is where? It is in the stain. So this tail part will go and join with this stain, right? In this way. It is leading to a three-dimensional structure called micelle. In this way, 100 to 1000 soap molecules get around this dirt, piece of this dirt or dust. Then if 100 molecules are joined in this manner, these are similar kind of chains. They will start repelling each other. When they'll repel, say this was dirt and they are leaving, they are having repulsions. When they are leaving, they are taking very small part of this dirt with them, right? All of them will take very small part of this stain they are taking with them. And again they are in soap solution, then again soap molecules will start combining near them, right? In this way, 4 or 5 times they will break down and their size will turn to the range of nanometers. Nanometers means very small in size and they can be washed off with water. In this way, your clothes will get clean. See this. This was stain and you are having this non-polar chains. They are going towards this oil part and this sodium end, which is positive part, is going towards water side. In this way, they are attacking on this stain and making a spherical structure, micelle, right? Then they will start repulsion and they will take up very small part of this stain with them. These small parts they are taking with them when there is repulsion. And again, soap molecules are coming near them and making again spherical structures. In this way, what we are doing, we are making emulsion. Emulsion is oil and water solution. Oil and water, otherwise they are not soluble with one another. But soap acts as emulsifying agent. It will help to make emulsion. When this oil will be dissolved in water, it can be washed off. Then you are having detergents. Detergents are long chain sodium salts of sulfonic acids. Where soaps will not work, like you are having situation where hard water is provided. In hard water, soap will not make lather, it will rather make scum. What happens? We are having hard water. Water is hard because of calcium and magnesium. Chlorides and sulfates. If water is having calcium and magnesium chlorides, sulfates, it is permanent hardness. And if it is having carbonates or hydrogen carbonates, then it is temporary hardness. Temporary hardness can be removed by boiling, but permanent hardness you need to remove with the help of ion exchanger, right? So if you are having calcium and magnesium chlorides or sulfates, then you are using soap solution, then what happens? What would be the procedure? It will not form lather, it will form scum. You are having calcium ions in water and you are using soap solution with it. It will form C17, H35, COO twice, as calcium is having valency of 2, plus 2 sodium atoms in the form of ions will move out. This is scum. It is not soluble in water. It will give you precipitate type things. If you are using hard water for cleansing, then it will not be helpful. It will not clean. Then what is difference between soaps and detergents? Soaps are sodium salts of fatty acids. Detergents are sodium salts of sulfonic acids. Soap you can use in soft water as well, but detergents you can't use. Sorry, soaps you can use in soft water, but not in hard water. Detergents you can use in soft water as well as in hard water. Soaps are biodegradable substances. They will not cause pollution, but detergents, they are non-biodegradable substances. So they will cause pollution. Too much accumulation of detergents and non-biodegradable things in river water will lead to a condition there too much algae will grow. It will cause the condition of eutrophisation. That's all about this chapter. Thank you.